You can set up GitHub so that whenever you make a change to your local database using an SQL file, it will get automatically run on another database, keeping them both in sync. This is great for the development and testing of anything that uses a database. Let's learn how to use GitHub Actions and GitHub to automatically update a remote database. Here is what we're doing in this video. We'll make a change to our local database, which is running on our own computer, just like a dev environment. This change will be made using an SQL command, which will be saved in an SQL file. This file is stored in a GitHub repository, which we will check in and see on the master on our remote repository, which is on the GitHub website. Now here's where the magic happens. We will set up a process to automatically look at this SQL file, connect to another database, and run this SQL file on that other remote database. This means the remote database will be updated to match our local database. All we had to do was check in a file. But how do we set this up? I'll show you how in this video. Let's get started. Our first step is to create a database on our local database server. We'll use MySQL for this demo, but the concepts should work on other databases. If you don't have MySQL set up, check out my other video here for step-by-step instructions on how to do that. So we'll connect to the local database which is running on my computer. Once we do this, we'll see a new query editor. For our process that we want to run automatically, we want to create a database, create a table and insert data into it. We'll start with creating a database. We write the command create database, then a name of Hawthorne. This will be the name of our database. Let's run this command on our local database, and the database is created. We can refresh the list of databases on the left panel here and see that it exists. The next step is to save this command as an SQL file to our repository. We'll save the file here in MySQL Workbench, and we're prompted for a file name and location. We'll use a name of hawthorne_script.sql. We'll also save it in the local repository. This means it is the local copy of our GitHub repository. If you don't have a repository set up, that's okay. I've created another video on how to set one up, which you can watch here. So we'll store the file in a new folder called Hawthorne. Click Save and the file is saved. Now the file is saved, we need to check it in so that it appears in the main or remote repository on the GitHub website. To do this, I'll open the terminal. You can use the command prompt if you're on Windows. I'll change to the directory that my repository is in, which is called database star. Yours will likely be different. You can watch that other video on setting up a GitHub repository for more information. We can run a command called git status. This will show us any files that we have saved on our computer that are not checked in or uploaded to the remote repository. We can see here our Hawthorne SQL script is shown because we haven't checked it in. We'll do that now. First, we run git add in order to add the updated files to the files that we want to commit. Then we commit it using the git commit command and add a small message. Then we run git push to check this code into the remote repository. After a few moments, the process should finish. We can see this file by going to the GitHub repository here. We can see the new folder is created and the file exists in this folder. We can also see the message here, which is what we typed in for our commit message. So we've checked in the file. We want it to automatically run on our remote database, isn't that right? Let's connect to this database now. I'm using a cloud-hosted database on Amazon RDS, but you can use whichever database you like. I've got another video on my channel on how to set this up. We use a cloud-hosted database so that the process that runs to automatically run the file can access it. If we run another database on our own computer, this process won't be able to access it. So let's connect to the database. I've already got a connection set up here, which I had covered in the other video. We can see that it is connected. We can see the list of databases on the left panel, but there is no Hawthorne database here. This makes sense. We haven't done anything to mention this database or connect it to anything with our new Hawthorne script. We could open the SQL file here and run it, but that's not ideal. The whole purpose of this video is to automate the process. So let's automate it now. The way we are going to automate this step is to use a tool called GitHub Actions. This is a type of continuous integration tool, and there are many others available. I've chosen to use GitHub Actions as it's popular and it's easy to start with. We want to get GitHub Actions to automatically run our Hawthorne SQL script on our remote database, which is on Amazon RDS. GitHub Actions does this by reading a configuration file that exists in a specific folder in our repository. To do this, we're going to create this location and this configuration file. I'll open up Visual Studio Code to do this, but you could use any other text editor. Once VS Code is open, I'll open the folder for my repository, which will allow me to work with the files. First, we'll create the folder. According to the GitHub Actions documentation, the folder needs to be called Workflows and must exist inside a folder called .github. Yes, there is a period at the start of the name. So create a new folder called .github, and inside that, a new folder called Workflows. Then inside the Workflows folder, we create our configuration file. GitHub Actions will run any files with a .yml extension within this folder, so it doesn't matter what name we give it as long as it has a YML extension. We'll create a new file called hawthorne.yml. A YML file follows a specific format. It's a combination of text values, colons, spaces, and other characters. It can get quite tricky to get a valid file, so if you have errors during this process, then don't worry as it's normal. There are a few things we need to add to this file. On the first line, we add a name for the job. I've called this one Hawthorne. On the second line, we add a run name, which will appear in another location on GitHub. In this example, we can give a short description. The next line we write on, which defines when we want this file to be run. We'll put in the command push, which means the script should be run whenever code is pushed to the repository. Next, we add the word jobs. After this, we add a new line. We can add multiple jobs here, but for now we'll add a simple job to output a line of text. We'll come back later and add more. Here are the commands we've added to this file. I'll add a link to this file on my GitHub repository to the video description if you want to use it. We add a job name of test output. Under that, indented by 2 spaces, we add the runs on command and specified Ubuntu latest, which means it runs on the latest version of Ubuntu Linux. Then we specify steps, which we can add multiple steps inside for the things to run. We add a dash, then the name to specify the name of the step, and we'll call it test output. Then we add a run command, and we enter the word echo and some text inside quotes. That's all we need for now. We don't need anything else to get this running. We haven't mentioned a connection to the database yet, but we just want to get this file running and working first. So save this file. We'll check it into our repository. To check in our file, we go back to the terminal like we did for the SQL file. We can use the git status command to see the status of our repository, which shows us any files that are changed or those that are included in the commit. We can run the git add command again to include our changes. We run the git commit command and add a message. After a moment, when that is done, we write git push. The file should then be on our remote repository. Now what? We can see what GitHub Actions does with this file. To access GitHub Actions, go to the repository on GitHub. Click on the Actions tab here. This page will show the different workflows you have set up. You should see one entry here called Hawthorne, which is our YML file we just created. If you have more than one file like I do, you can select the file to view on the left sidebar here. In the main part of the page, you can see a history of the actions that have been run. It runs once for each time you push, so you should see one entry here. It will show the run name that you provided in your file, and a green tick if everything is okay. If there are errors, it will show a red X and a message of the commit. I get errors quite a lot when I check in, mostly due to syntax errors in my YML file, so if you get an error, it's pretty common. Click on the entry in the main part of the screen here to view more details. You can see some details about it, such as how it was triggered and how long it took. You can see one step here called test output, which is from our YML file. So that's how the file maps to the screen. Click on the test output and you can see a log of the steps that were run. Click on the icon to expand the section and you can see some output including the echo step that we ran. So if you got a green tick and can see this, it's working so far. GitHub Actions successfully looked at this YML file when you checked code in and ran some steps automatically. Now let's make GitHub Actions connect to our remote database and run our SQL script. We'll add another section to our YML file. You can remove the test output step if you like, but it's small, so I'll leave it in. Our new section is called Connect Remote, because this is where we will connect to the remote database. Once again, we'll add in runs on and specify Ubuntu latest. We add in the steps keyword and go to a new line. We'll add in a line here called users, which will let us run another job. We'll specify this one called Actions Checkout v3, which from what I understand will allow us to check out code in the repository so it can be run as part of our action here. Next we add in the name command. We'll run a simple show databases command on the remote database just to get something working. So we will call this show remote databases. After the name we add a run command. The run command here is where we can run the MySQL command. It's like running MySQL from a terminal. We specify MySQL, then the connection parameters, then the command to run. Here's the basic command. We have -h, then the hostname, then the port, then the username, then the password. We then specify -e, then run show databases. In order for this to run, we need to specify the hostname, username, and password. Let's enter this into our command. Wait a minute. If we enter this information, our hostname, username, and password into this YML file, it will get checked into our repository. It will be visible to anyone who can view the repository, meaning anyone can access our database. We don't want to do this. How can we connect to the database without entering our details on the command line? We can use a feature called GitHub Secrets. It allows us to add some parameters or variables to our GitHub repository and refer to them by name in our script instead of the actual values. It means nobody can see our database connection parameters, but the script will still run. Let's do that now. To add a new secret, go to the GitHub website. In the repository you're working on, click on Settings. Make sure this is the settings for the repository here, not the settings on your profile button on the top right. Once the settings page is shown, under the Security section, click on Secrets and Variables and then Actions. Click on the Secrets tab. We're going to create 3 secrets, one for the hostname, one for the username, and one for the password. To create the first secret, click on New Repository Secret. Enter a name for the secret. We'll enter DB hostname as our secret. Add the value for your secret. On Amazon RDS, this is available on the Connection tab and is the hostname that you would use to create a new connection in MySQL Workbench. Your value would be unique to you. Click Add Secret. Now we'll add another secret for the username. Repeat the same steps using a name of DB user and the username you have for your remote database. Finally, we'll create a secret for the DB password called DB password and add our value. So our secrets are in our repository. Let's go back to our YML file and refer to them. To use the secrets in the YML file, we add in some syntax to refer to the secret. This means we add a $, then 2 curly braces, then a space, then secrets, then dot, then the name of the secret, such as db_hostname. We then add a space, then 2 closing curly braces. Repeat the same thing for the DB user and password. One thing to remember is that for MySQL, the username and password values go directly after the -u and -p commands. There is no space in between. It seems odd, but if you add a space, you'll probably get some kind of connection error. This is what our command looks like. I'll have this file saved and linked in the description below for you to use if you want. Let's check it in. Back in the terminal, we can run the git commit command and then git push to check our code in. This should trigger another workflow on GitHub Actions. We can check the action page again and should see another entry in the table, and hopefully it has either a green tick or a circle here indicating it is in progress. If it's still running, it should update to green or red automatically when it's done. There's no need to refresh the page. Once it's finished, click on the entry to open the details. We can expand the steps to see the log. Now we should see a list of databases here from the Show Databases command. Success! We've got the script to connect to the remote database and run some SQL. Is this the right list of databases? Let's connect to the remote database in MySQL Workbench to check. Back in MySQL Workbench, we have connected to the remote database here. We can see the lists of databases on the left, and it matches what was shown in GitHub Actions. There are a few databases shown in GitHub Actions and not in this list, but that is because they are system databases and MySQL Workbench doesn't show them. But we haven't run that SQL script to create the new database. Let's do that now. Back in our YML file, we'll add one more step. This step will connect to the remote database and run our SQL script. Fortunately, we can copy the previous step and make a slight modification. You could remove the Show Database step if you like, but for this example, we'll keep it. Add a new line here for the name, and we'll call it Run a Sample SQL on Remote. On the next line, we have the Run command. We can copy the Run command from the previous step. Everything is the same except for the command at the end that we run. Instead of Show Databases, we want to run an SQL file. We do this by entering the word source inside the quotes. Then we specify the path to the SQL file from the root folder, which is Hawthorne, then / then our SQL file. It should look like this. I'll have the link to this script in the description as well. Now this should connect to the remote database and run this SQL script automatically. To trigger this, we'll need to check in our changes. Back in the terminal, we run the git commit command with a message. Then we run git push and wait for it to complete. On the GitHub Actions page, we should see another entry for the workflow. Once it's finished, we can click on it to see the details. With any luck, all of the steps will have passed. We can see the command here that ran the SQL script. Now let's check our remote database to see if the new database was run. Back in MySQL Workbench, we can refresh the list of databases on the left. We can see that the Hawthorne database was created. This is nothing short of magic in my opinion. Here is what we did. We wrote an SQL file and wrote a configuration file so that whenever we check in code, an SQL script is automatically run on a database. This is just the basics of a process like this. Also, I'm still learning about using this process, and it may not even be the best practice. So if you have any experience doing this, feel free to point out anything I'm doing wrong or any improvements in the comments section. There's also a tool called Flyway that can be used to make this process easier, and I'll create another video on that in the future. So we've got our database created. Let's create a table and add some data. How do we do this? We can update our SQL file to run these commands. Our SQL file is run completely on the remote database. So once we create the database, we can add a create table command and an insert command. Let's update our SQL file. We'll create a simple table here with a couple of columns. After that, we'll add an insert statement that inserts some records. Now let's run the whole script. If we do, we get an error saying the database already exists. So let's drop the database first using the drop database command. Also, we need to specify that the new database should be used to create our table when we create the database. So let's add in the use Hawthorne command. We can run the entire script again and it should work. In another tab here, I'll select from our new table. We can see the results on our local database. Now save the SQL file which has the create and insert commands in it. We don't need to make any changes to our YML file because that has already been configured to run this specific SQL file. Once the file is saved, go back to the terminal and commit the file using git commit. Then run git push to push the file to the remote repository. We can then open GitHub Actions and see the new entry here. Once it's completed, we can see the logs. Assuming it is successful, we can see the logs here. We'll see any output from our SQL statement. Let's check our remote database to see what it looks like. In MySQL Workbench, refresh the database list on the left. We can still see the Hawthorne database. Now write and run a select query on this table we created in our SQL script. When we run it, we can see the output here. This is incredible. We got our table created and data inserted automatically. All we needed to do was write SQL, save the file and check it in. The rest happened automatically. There is so much more that we can do with a process like this. We can add testing of our data and database. We can create separate SQL files to run one after the other. We can add more tables and records. We can add in more logic to the process. We could also use a more sophisticated and easy tool such as Flyway or Liquibase. But this video is just a demonstration of the concept and to get the basics working. Let me know if you have any questions or comments or ideas for what other things you'd like to be able to accomplish with a process like this in the comments below. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you like this video, subscribe to my channel. Thanks for watching.